Hello and welcome to this video on linear regression, and in particular how to interpret a linear regression model and how to assess the validity of a linear regression model using residuals. As a very quick review, a linear regression analysis takes data in the form of x, y pairs and creates a linear regression model of the form y hat is beta 1x plus beta 0. Where beta 1 and beta 0 are the linear regression coefficients. Once we've created this model, we can use it to predict y values for given x values. Here's an example. From this data set, I've created a scatter plot and fitted a line to it, which gives me a linear regression model. From this I can see that beta 1 is 1.985 and beta 0 is 0.319. So if I want to use this linear regression model to predict a y value that I would get for a certain x value, so for example, suppose x were 10, I could find the predicted y value as where again this is beta 1 and this is beta 0. So that's how I can use a linear regression model to predict y values from given x values. Another thing that the linear regression shows us is that r squared, which is the coefficient of determination, for this case is 0.99557, etc. This is very close to 1. What this means is that our data fit a straight line very well. I can assess the validity of my linear regression model by creating what's called a residual plot, and I do that as follows. For each x value, I create a value y hat I, which is the predicted value, so that's beta 1 xi plus beta 0. And then for each predicted y value, I create a residual ei, which is the actual y minus the predicted y. I've used this spreadsheet to compute the predicted y value. Again, you can see that this is my linear regression model. And from the predicted y value, I've computed the residual of the actual y value minus the predicted y value. This graph is called a residual plot. It shows the predicted value on the horizontal axis and the residual value on the vertical axis. If my linear regression model is a good model, then my residuals should look like they're randomly distributed as I move from left to right. And you can see that these residuals look reasonably randomly distributed. There's two high values here, which I think are a little bit disturbing, and there seems to be a little bit of a trend in that these values are not centered around 0. But for the most part, this looks like a pretty good residual plot. Let's see what happens when the linear regression model is not a good model for the relationships in the data. Here I have another data set where again the xy values are plotted on this scatter plot. I fit it with this line, and you can see just by looking at it that this line is not a good representation of this data set. I created a residual plot in the same way as I did for the previous data, with the predicted value on the horizontal axis and the residual value on the vertical axis, and you can see that this has a very definite pattern. Again, if the residual plot has a very definite pattern, it means that our linear regression model is not a good model for the data. And here's a third example. This shows a scatter plot of the data, and you can see the line that I fit to it, which seems reasonable. When I look at the residual plot, it looks like this. You can see for the points over here that there's a wide variation between the magnitudes of the points. They're centered around 0, but the variation is still quite large. But for these points, there's a small variation. This is a sign of what's called heteroscedasticity, which means that the magnitude of the residuals depends on the predicted value. This is typically considered to be a sign that my linear regression model is not a good fit for my data. So in this video, we've talked about how to use a linear regression model to predict y values for given x values, and then we've talked about using residual plots to determine whether or not the linear regression model is a good fit to the data. I hope you found this video helpful. Thanks for watching.